Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about higher order derivatives. And we're going to do some critical thinking questions here. And we're going to find the indicated derivative with respect to x. So this isn't your standard derivative here. If I was given this function, y equals 99x to the 99th power, okay? And we wanted to find the 100th derivative, d to the 100th power, of y over dx to the 100th power. Okay, so let's go think about this for a second. Okay, we're going to take our time with this. Okay, this is obviously not something that you're going to multiply everything out. We're going to try to attack this differently. Okay, so what I like to do is do a few steps here so I can see a pattern going on. So I'm going to take the first derivative. I'm going to write it right here, dy dx. The first derivative would be the 99 comes down, so 99 times whatever 99 we had there, x to the 98th power, okay? And that's our first derivative. So I'm going to put a little 1 here, so it's like 1, right? First derivative. Second derivative, if I did that second derivative, d to the 2 power y over dx squared. The 98 comes down, so we have 98 times 99 times 99 times x to the 97th power, okay? Well, we keep doing this to a third one here, third one. D to the third power y over dx to the third power. 97 comes down times 98 times 99 times 99 times x to the 96th power. Okay? So as I keep taking my derivatives and keep going down more and more, we're going to keep subtracting our exponent by 1 and bringing or multiplying it down and subtracting by 1. Okay? So now let's try to predict what's going to happen when we get down to our, let's say, 100th derivative. What's going to happen on the 100th derivative or the 99th derivative, right? So the first derivative gave us the 99 down here, 98 down there, right? Second derivative, 98 down here, 97 was up there, so we keep subtracting. So every derivative we subtract the exponent by 1, right? So our first derivative is subtracted by 1, second derivative is subtracted by 2, third derivative is subtracted by 3, and so our 99th derivative, we subtract the exponent, whatever it is, right, 4. So we have x to the, well, 99 divided, or sorry, not, the 99th derivative, not fourth derivative, the 99th derivative there. We subtract our exponent by 99, so we're going to get a 0 up there, okay? A 0 up there. So if we remember, each derivative, we're subtracting the exponent by 1. So the first derivative, we subtract by 1, get 98. 99 minus 1 was 98. Second derivative, subtract the exponent by 2, 97. By 3, 96. And we added whatever that exponent was previously out in front. So our d to the 99th derivative of dx to the 99th power would equal to 1 times 2 times 3 times ... forever. Not forever. To 98 times 99 times 99. Okay. So that's still a very big number. But x to the 0 power is just 1. So at this point, our derivative is just some constant. It's some massive number, some big number, right? 1 times 2 times 3 times forever, all the way up to 99. Times x to the 0 power, which is just 1. Well, when I take the 100th derivative, d to the 100th power, y over dx to the 100th power, this is just a constant. Since it's just a constant, the 100th derivative there is just going to be 0, right? Because the derivative of a constant, no matter how large it is just 0. So let's kind of recap what we did here. We're given y equals 99x to the 99th power, and we need to find the 100th derivative of that. Now, obviously, we're not going to do 100 steps. It's not really what this problem is trying to get you to do. And you could do it that way. It would take forever, and you would come with this conclusion. We're trying to save some time, and that's the whole point of this critical thinking here. I do a few derivatives in a row, but I don't multiply it out. I keep my numbers out here, separated, so I can see what's going on. I see the exponents are going subtracting by 1 with each derivative, so I said, okay, and I can see a pattern going on here. So I try to recreate that pattern to the 99th one. So if I subtract our exponent, 99th power, right, subtracted by 99, give me x to the 0 power here, and our 99th derivative would be 1 times 2 times 3 times 4 times 5 times 6, forever. Again, not forever, until the cows come home. And we keep going until we got 98 times 99 times 99 a second time, times x to the 0th power. Well, x to the 0th power is just 1, right? X to the 0th power is just 1. And so this whole thing is some large number, some very large number, okay, but it's still a constant. And so when I take the 100th derivative, right there, like the 100th derivative, I put that little say into the 100th one. 100th derivative, well, the derivative of a constant is always going to be 0. And so our final answer here is d to the 100th power y over dx to the 100th power is just equal to 0.